Hi, in today's lesson we're going to talk about exponential growth and decay. Here is our learning target. And so exponential growth, as you probably have heard in the news recently, that phrase has come up because it represents what we've been talking about with the coronavirus and how it spreads. The goal right now is to get the curve to slow so that it actually becomes something more like, it's called a logistic curve, but right now we're in this period where it's growing, and we're trying to figure out ways to impede that growth. So when we look at characteristics of exponential functions, first their graphs are curved, so you'll notice the graph on the left that represents an exponential growth. The one on the right is an exponential decay. When we look at reading these graphs, we read them from left to right. So notice on this graph, as we read from left to right, it's increasing. And here, same thing. This one, as we go from left to right, you can see it's decreasing. Okay. The second thing is they have parts of their graph where they increase very rapidly or they decrease very rapidly. The rapid increase on the one on the left is right here, and the rapid decrease on the one on the right is right here. Also, exponential functions, the last thing is they get really, really close to a line, but they will actually never touch that. In this case, that line is, in this first graph, is this what was green, okay? That graph over on this section gets really, really close to that line, but never really touches it. Over here, this is the line here, and on this part, it gets really, really close to that red line. The green line gets close to that red line, but never actually touches it. That red line is called an asymptote. We won't really talk about asymptotes too much other than to just know that the graph kind of levels off at some point, or it gets really close to something there. All right? Okay. So we already mentioned this in the previous video. An exponential function looks like this when you are writing it out. This first thing here, this is where that's your starting amount. And then the second one, that's your multiplier. Okay, so when you see exponential functions, you should see one of those. Sometimes you won't see an A because the A is 1. So how do we know if it's a growth or a decay? Remember, a growth, when you graph it, it should look kind of like that. If a decay, when you graph it, it should look kind of like that. But if you're looking at a graph, it's pretty easy to tell. However, if you're looking at an equation like this, how do we know? So what you want to do is look at the b value. If that b value is bigger than 1, it's a growth. If that b value is in between 0 and 1, it's a decay. Okay, so let's take a look at this next slide. Before we do that, this I just put in here because it kind of emphasizes even if your multiplier is just a little bit above 1, and you multiply that for 365 days, you would at the end of the year have 37.8. Even if it's just a little bit below 1, like 0.99, and did that for a year, you would end up with 0.03. So the difference between our original b values is very, very small, but at the end, the difference is much, much greater. So this kind of emphasizes exponential functions and their growth or decay. Okay, so here's what I was talking about. In this case, we need to determine whether they're growth or decay and then graph them. And you're going to do this graphing on your graphing calculator and then just quickly sketch that when you have your assignment. So you're going to look at your b value for both of these to determine what's happening. So my b value in this case is 3/4. Because that's between 0 and 1, this would represent a decay. All right, and then let's take a look at b. Part b, then my multiplier in this one is 1.05, which isn't much bigger than 1, but it's still bigger than 1. So this actually would be a growth. And when you graph these, hopefully that will show that as well. So that's what we're going to do next. And here's where you'll need your graphing calculator. So on your iPad, find the MCA calculator. You're going to go to the grades 8 and 11, and then just press start until you get to here. And then go to the top. Okay, now I got my graphing calculator. Same one you have in class. We're just going to type in this function. Our first function was 10 times 3/4 to the x power. And normally you'll just go to graph here, but when you're doing exponential functions, we want that to be zoomed in a little bit more. You can see the curve there, so it looks like we're okay. It's also decaying as we said it would. But this time when we graph these I want you to use zoom and then zoom fit. You can't see that one here. It's all the way down here at 0. So you can press 0 usually, but I wanted to show you that. So now if we press enter, now this will be actually the graph that I want you to write down. So we'll sketch this in our on your assignment, in this case in our notes. So in this video, I'm just going to sketch okay, looks something like that. All right, so let's do the second one. It says f of x is equal to 100 times 1.05 to the x power. So let's go back to our graphing calculator. Okay, and hopefully we said this was a growth, so when we zoom fit, you can just press 0 if you don't want to scroll down. Hopefully you see a growth. And we do here, you can see it looks like it's a slow curve. It's actually going pretty fast, but we're really zoomed in. So that's why. So I want to sketch this. Okay. And that's all you really need to do. So hopefully now you know how to determine whether it's an exponential growth or decay, and you know how to graph it on your graphing calculator. All right, see you later. Take care. Bye.